So, hello everyone again. I welcome you again to the third part of lecture 5 of electromagnetic induction. I am Samir Lavankar. So, let us begin our discussion again. So, the course outline we were talking about was induction, moving on to the experiments of Faraday and Henry. Just to reiterate to you, there were 3 experiments: experiment 1, experiment 2 and experiment 3. Experiment 1 involved a coil C1 and a bar magnet. Let me denote bar magnet by M. A moving of bar magnet either towards the coil or away from the coil will deflect the galvanometer and the current passing through, and the current will be induced in coil C1, or in different sense if the bar magnet is kept stationary and the coil C1 is pushed towards bar magnet M or away from the coil or away from the bar magnet, then the galvanometer will also show an induction. Coil C2 involved 2 coils C1 and C2. A similar concept was being dealt with if the coil C2 was being powered using a battery and it is moving either towards the coil C1 or away from the coil C1, and vice versa, that if the C1 is passed through a battery, is passing through a battery, and coil C1 is pushed towards coil C2 or away from coil C2. And then third involved again 2 coils, but this time a tapping key was being used. A tapping key was being used, denoted by K, for the complete experiment. So, these were 3 basic experiments, 3 major experiments which involved or which evolved of the concept of electromagnetic induction. Moving to the magnetic flux value, magnetic flux is nothing but phi b, which was a dot vector product of B and A. What is B and A here? B is nothing but magnetic field and A is nothing but the area vector. What is theta? What is theta is the angle between B and A value. So, phi b is nothing but B dot A, which is equal to B multiplied by A multiplied by cos theta. So, this was the concept of magnetic flux we talked about in lesson 3. Moving to the Faraday's law of induction, Faraday's law of induction was nothing but epsilon is equal to minus n d phi b by dt. Lenz's law and conservation of energy, in which the concept of why this negative sign comes into picture and why there was an induction of current which opposed the value of change in flux. So, that concept is being talked about in Lenz's law and conservation of energy. Moving on to the motion electromotive force, in which we found out that only and only change in magnetic field does not take into picture the induced EMF. It can be also due to the change in the area. So, a similar concept was being used, and for a conductor, for a rectangular conductor moving inside or outside led to the change in the induced EMF, and the value we got was epsilon is equal to B into L into V. And now we were talking about the inductance value. In the inductance concept, we already talked about mutual inductance, and now a further discussion is to be done in the concept of self inductance. So, let us move on to self inductance, further discussions. So, till now in the last lecture we talked about that n phi is nothing but flux linkage is equal to L into I. So, what is L value here? L is nothing but coefficient of self induction. Just to reiterate to you, if mutual inductance is being talked about, then n phi is equal to m into I, but for mutual inductance 2 formulas are being involved. If we are talking about the flux linkage in coil or solenoid S1, then the current would have been passing through coil or solenoid S2. If we are talking about the flux linkage in solenoid or coil 2, then denoted by N2 phi 2, but the current will be passing through coil I1 or solenoid S1, not coil I1, coil or solenoid S1. But in self inductance concept, there is no use of neighboring coils, only a single coil is being used, and hence there is no requirement of denotation by any numbers in the subscript. So, it directly n phi is equal to L into I. So, M is used for mutual inductance, and L is used for self inductance. So, please make sure of this concept. Let us move on. So this was being tagged, and also value of epsilon we found out that the EMF induced when the current is varying with time is nothing but minus L di by dt. Let us move on to the further discussions. So now please listen carefully again. Thus the self induced EMF, self induced is because the induction is being done in the same coil, that is why it is called as self induced. EMF is nothing but voltage value denoted by epsilon, always opposes any change of current in the coil, opposes any change of the current in the coil. So that is why a negative sign is used here, that is why a negative sign is used here. So thus the self induced EMF also always opposes any change of current in the coil, that is if the current is being increased, then the value of EMF we will get is in the opposite direction. If we will get this value as positive, then the EMF induced will be negative, positive, negative. If the current is decreased, that is di by dt is negative, then the EMF induced will be positive value. So now it is possible to calculate, iterating this line again, thus the self induced EMF always opposes any change, that is either increase or decrease of current in the coil. It is possible to calculate the self inductance, self inductance is denoted by value of L. It is possible to calculate the self inductance for circuits. Please make sure if the circuits concept is used, if the circuit word is used, then it is always a closed circuit. It is always a closed circuit here talked about. So now it is possible to calculate the self inductance for circuits with simple geometries. Let us calculate the self inductance of a long solenoid. Long solenoid is, what does long solenoid means? Long solenoid has an assumption in the name only that L is greater than R. What is a solenoid? A coil like this is a solenoid. Let me denote the solenoid by S. So let us calculate the self inductance of a long solenoid of cross sectional area A and length L. So the cross sectional area is given to you as A, and the length is given to as small l. Having n turns per unit length. So n turns per unit length is nothing but n is equal to, if the number of turns is capital N, then small n is equal to capital N divided by L. Having n turns per unit length, the magnetic field due to a current I flowing in the solenoid B is mu into n into I. This is the similar concept we talked about when we were talking about mutual inductance. So B is nothing but mu naught into n into I. What is n? N is the number of turns per unit length. What is I? I is the current passing through the solenoid. Again an assumption is being used here, that neglecting edge effects. So it is an assumption again. This assumption is being kept so that the value of B we are implying here should be constant. It should not vary either with space or with time, because sometimes leakage also happens in anything which is real life. Every time leakage happens, and hence to make conditions ideal, to make things involved, that everything is kept ideal here, to make that thing, this assumption is being used here. Moving on, the total flux linked. What is flux linkage? Flux linked is nothing but n into phi value. This is flux. Flux linkage. So the total flux linked with solenoid is n phi is equal to, I already told you, n capital N is equal to small n multiplied by L. So capital N is equal to small n multiplied by L. So this is directly used here, and mu naught Ni was the value of B here. The value of theta here is 0, so cos 0 is 1, and the value of A can be anything which is having simple geometry. See, it is written here that we are talking about simple geometries here. Simple geometries. If the solenoid is being talked, then it is quite evident that the value of cross sectional area will be the cross sectional area of a circle. So hence the value may be or should be pi r square. This should be the value of area. So mu naught. So just iterating, mathematically evaluating the stuffs here, we get n phi b is equal to mu naught n square A L I, where small n into small l is the total number of turns. Thus the self inductance is, so how we will get this value is nothing but this, we already knew from the previous slide that n phi b is equal to capital N into I. So, just using this equation, let me write this equation as equation number 1. Then using both these equations we get n phi b is equal to capital L into I. Here I can get cancelled, therefore capital L is nothing but mu naught n square capital A into small a. So, what can be understood from this concept is that the value of self induction or coefficient of self induction is a function of, it's a function of mu, it's a function of small n, it's a function of area, it's a function of length. So, this is the concept we can understand from this formula which we calculated using equating the two concepts, equating the two equations, where small n into small l is the total number of turns, thus the self inductance is mu n square capital A into small l. Moving on, again as we talked about in mutual inductance also, the formula is kept here for a quick reference, that if the air is the medium then mu r is equal to 1, but if the medium surrounding the coil is not air, then the relative permeability, the coefficient of relative permeability to be used should be of that particular material or that particular surrounding. So, that time mu r has to be multiplied with mutual induction. Similarly, here also value of mu r has to be multiplied with the value, with the formula of self induction. So, just reiterating the concepts written here, if we fill the inside of the solenoid with a material of relative permeability mu r, for example soft iron which has a high value of relative permeability, then capital L is equal to mu r multiplied by mu naught into n square into capital A into small a. Let us move on to the next concept. So, the self inductance of the coil depends on its geometry. See, it depends on geometry. I will iterate it like this: it depends on geometry and on the permeability of the medium, The self induced EMF is also called the back EMF. So, a new concept, a new definition is got here, that self induced EMF is also denoted by self induced EMF is also known as back EMF. So, a self induced EMF is also called as back EMF. Why is it called back EMF? As it opposes any change in the current in a circuit. From the last concept, when we were talking about the value of induced EMF, we got to know that epsilon is equal to minus L di by dt. Let me write the formula here again. EMF induced is equal to minus L di by dt. So, any positive change, any change in the current value will have a negative effect or will have an opposing effect. Why it will have an opposing effect? Due to this negative sign. Negative sign is involved here. So, that is why let me iterate this again. The self induced EMF is also called back EMF as it opposes any change in the current in a circuit. So, this is the only concept being talked in this point here. Physically, moving on, physically the self inductance plays the role of inertia. If you remember what is inertia, inertia is nothing but a resistance. You can understand this concept by resistance. What is inertia? It is the back force being calculated here. If you are trying to move forward, then inertia tries to oppose that motion. So, that is nothing but inertia. So, physically the self inductance plays the role of inertia. It is the electromagnetic analog of mass in mechanics. So, it's, if we are talking about it's a self explained line, that if you are talking about mass in mechanics, that mass in mechanics can be denoted if you are concluding anything in electricity, if you are concluding anything in electromagnetic induction, then that concept can be analogous to the can be analogous to the self induction part, the self induced part, self inductance part. So, the work needs to be done against the back EMF in establishing the current. So, some work has to be done to resist that force. To resist that force, some work has to be done. If you are moving like this, then some resistance has to be involved like this. So, what is the work done in doing this back part, in doing this back work? So, let us calculate that thing also here. So that is why this point was being iterated here. So work needs to be done. A work needs to be done against the back EMF in establishing the current. What is back EMF? Back EMF is nothing but the EMF, the current induced due to self induction. So the work done the work done is stored as magnetic potential energy. Please make sure here that is stored as magnetic potential energy. So it is a type of potential energy only, as magnetism is involved here, it is also a magnetic concept or magnetic word is being added here. So work done is stored as magnetic potential energy. For the current I at an instant in a circuit, the rate of work done is, for a current I at an instant. So a particular instant is being talked about here, a very small value, a very small time frame has been used, and that in that time frame the value of work done is calculated. So for the current I at an instant in a circuit, the rate of work done is, dw by dt is equal to epsilon into I. So this is a typical physics equation, that the work done, the change in work done is nothing but epsilon into I. If we ignore the resistive losses, as for ideal conditions we always remove all the leaky things, or we in the last concept also we were talking about one of the assumption that edge effects has to be neglected. So these all things are being used, or these assumptions are being kept so as to find out the ideal thing. Every small errors are being removed so as to find out the ideal equation. So if we ignore the resistive losses and consider only inductive effect, is being used, then we get dw by dt is equal to Li di by dt. How is thing being talked about? We are finding out the value of epsilon. What is the value of epsilon? That is equal to minus L di by dt, but the mod value of epsilon will be nothing but L di by dt. So directly this concept is being used here. Epsilon is equal to di by dt, and because it has been multiplied by value of I, so it is nothing but Li di by dt. Moving on, the total amount of work done in establishing the current I is, we just removed dt dt from here, and then dw is nothing but L I di. If we integrate it, the value of current established will start with an initial value of 0, it will go to the maximum value of I. So therefore dw will be work done complete, and this will be nothing but L is constant here, it will go to 0 to I di. We know this integration, this is nothing but L I square by 2 from 0 to I, which is equal to L I square by 2. Hence the energy required to build up the current is, the energy required to resist the flow, the energy required to do the work, as it is analogous to inertia. So anything which is work required to build up that energy, build up that current, is the work done here, and hence this work done is nothing but W, which is equal to half L I square. So this expression I will convey to you in the next lecture. For now, let me recap what was being talked about in this lecture. So we started with the concept of self inductance again. We started with how is it analogous to mutual induction, what was different here, what all things is a function, what all things are function of self inductance concept. So directly we found out that n phi b, let me change the color here. So as a recap value, so this was already being talked in last to last lecture. This value of self inductance was being talked in the last to last lecture. In this lecture we found out this formula that n phi b is nothing but mu n square into capital A into small n into I. Hence the value of self induction, hence the coefficient of self induction was mu naught n square into capital A into small n. Moving on, we found out that if the value of material is changed, if it is not here, then it has to be simply multiplied by the value of coefficient of relative permeability, which is mu r. Hence capital L will be equal to mu r into mu naught into n square into capital A into small n. And finally we found out what was the work done involved, and work done involved was nothing but W is equal to half multiplied by the coefficient of self induction into square of the current passing through it. So for this lecture this is concluded, and just to tell you about the course progress here, just to tell to you the course progress here, lesson 1, lesson 2, lesson 3, lesson 4, lesson 5 and lesson 6 are completed. Here mutual inductance is being completed. We are talking about self induction. Small problems will be dealt after the concept of self inductance has been completed thoroughly, and finally we will move on to the AC generator concept. After this, your complete electromagnetic induction chapter is being talked about. So finally, thank you.